Okay, so here's homework number 7. First question, this will be a pretty easy section, I think. Find the additive inverse of 5. That's just -5. They just mean the opposite sign. Number 2, wasn't that easy? Number 2, evaluate. So negative absolute value of -14. How do we do that? Well, you know that the absolute value symbols, they make the inside. So absolutes make the inside positive, then vanish. So they'll make it positive 14. Now that negative on the outside, this guy, he's still there. So it ends up in the end equaling -14 because of the negative on the outside. But the one on the inside was made positive, but the one on the outside still was there, so the answer is -14. Okay, here we are, number 3. Certain stock dropped 15 points, and the following day gained 24. What's the net change? It dropped 15, so that's negative, gained 24. So what's the result of that? 24 minus 15, what's that? Up 9. It's up 9 overall. If it went down 15 and up 24, it's up 9. So that'd be up 9. Next question. Temperature was -13 and it rose by 4. So -13 add 4, what is that? -9. And C, 60,000 feet dropped 4,000 feet. 60,000 feet dropped 4,000 feet. New altitude, 56,000 feet. Okay, so number 4. These are diagrams. These are ways of modeling positive and negative numbers. That's what this section is all about, positive and negative numbers, and how we first show kids about positives and negatives and how they all work together. Some of those little future engineers and stuff will need to really understand this well. So -8 minus -2. Now I know you all know the rules, that you could just, make that -8, and then the double negative is +2, and so that comes out -6. I know you know those rules. This is not about math rules like that one, which is a true and good math rule, but this is about why. Like if a kid asks why in the world do those two negatives make positive? Why in the real world does that happen? That's what this is all about. Modeling is to give a real life feel. Well, here's why. If you start with -8 items and you take away from it 2 negatives, you end up with 6 negatives. Now, which one of these, A, B, C, or D, shows that? Which one starts with 8 negatives? 1, 2, 3, 4, 5, 6, 7, 8. There's 8. But they're taking out 4 of them, aren't they? So that's not right. You're only supposed to take out 2 of them. 1, 2, 3, 4, 5, 6, 7, 8. Here we are. They're taking out 2. That's perfect. So B is our answer. C is taking out 3. D is only taking out 1. So B is the answer. You start with -8. You take -2 out. What's left? -6. See, that shows the truth of this statement, that this statement is really right. It really is right to make those 2 negatives positive, because -8 plus 2 really is -6, as we can see from this diagram. If you have -8, you have 8 red chips, which are all negative, and you take 2 of them away, you take away 2 negatives, right? That's what subtract -2 means, doesn't it? It means, because subtraction means take away, right? Take away 2 negatives. So, kind of scribbled this all up now. So if we take 2 negatives out, take away 2 negatives, what are we left with? 6 negatives. And originally we started with 8 negatives. So that's correct. Let's try B. B, here's what we're supposed to show. I grabbed it from up above. 8 plus -2 is 6. Okay, do you see it right here? It's this one, right? It's A. because there's 8. 1, 2, 3, 4, 5, 6, 7, 8. And then negative 1, negative 2. 8 add negative 2. See, this negative and this positive cancel, this negative, this positive cancel, and we're left with 6, aren't we? It equals 6. See how that diagram shows it? The other ones don't. This is just negative 1. This is negative, I don't know what, 6, 8. That's not right. This is negative 4. It's supposed to be negative 2 and positive 8. So A is the right answer. Okay, so how does number 5 work? Negative 4 minus 2x. So remember from earlier math classes, algebra and stuff, what a negative does in front of a fraction. That negative distributes, so we get negative 4 minus 4 plus 2x, right? When this negative hits that negative, two negatives make positive, and then negative 4 minus 4 is negative 8 plus 2x. That's the answer. Okay, here we are in number 6. For which integers a, b, and c is this equal to that? Well, the left side is a minus b plus c, but the right side we can simplify. Here, let me bring it down. What do we do with this minus sign in front of parentheses? We distribute it, and so it becomes a minus b, and when this minus hits that minus, plus c. So this comes out the same as the left side was. So they're the same. They're always the same. So our answer is A here. The equation is true for all integers, a, b, and c. Oh, no, I'm sorry, it's not A, because they said only for c greater than 0. No. It's true for every a, b, and c. We want to choose c here, which says equation is true for all integers, period. See, the other ones all give conditions. Only c greater than 0, only b greater than 0, only b minus c greater than 0. No, it's true this equals this equals this for all integers, like any a, b, and c. That's true. That's true for any number. A, b, and c can be any number, and that'll be true. That's what it means to show something is true with letters. If it's true with letters, it could be true for any numbers because those letters could be any number. That's why in higher math we prove things with letters. Once we've proven something with letters, we've proven it for all possible numbers. Okay, number 7. Use patterns to show that negative 1 times negative 1 is positive 1. Well, A is a beautiful pattern. Look at this. 3 times negative 1. Let me write it out here. 3 times negative 1 is negative 3. 2 times negative 1 is negative 2. 1 times negative 1 is negative 1. 0 times negative 1 is 0. Now, what comes next? Look at it. Just follow the yellow brick road. Follow the pattern. Here, let me bring it. I'm kind of out of room. Let me bring it down here. Up. Okay. So suppose, here's the thinking. Suppose you had no idea what negative 1 times negative 1 equals. I know you all know the rule that two negatives make a positive and everything, but why? What if you had a really thoughtful child that said, why? Why did two negatives make a positive? You could tell the child to sit down and quit bothering you, or you could try to give him a better answer. So here's a better answer. Look at this pattern. 3, 2, 1, 0. What comes next? Negative 1, right? That's just next in the pattern, right? 3, 2, 1, 0, negative 1. Okay. And then look at the answers. We haven't done the last one yet. Suppose we're trying to discover what the rule is. Suppose we have no idea what negative 1 times negative 1 is. We're just going to follow the pattern. Math is patterns. And see what happens. Negative 3, negative 2, negative 1. Whoops, I put the wrong answer here. It's important to have the right answer if we follow the pattern. 0 times anything is 0. There we go. Anyway, what's happening every time? How do you get from negative 3 to negative 2? You go up 1, huh? Negative 1, you go up 1. 0, you go up 1. So one more time, go up 1. You got to be positive 1. Look at that. Two negatives do multiply to be positive 1 just based upon the pattern. That's what A is saying. The other ones are not the right pattern. Okay, take a look at number 8. I want to use a number line model. Again, models are all about giving a feel to the kids of math, because math is not only supposed to, don't just about rules, but also about feeling the numbers, which might sound weird, but these models help us. 4 times negative 3. Which one of these models shows 4 negative 3's? See, it's B, isn't it? See, this is negative 3, goes back 3, and negative 3, and negative 3, and negative 3, 4 times, and the answer is negative 12. That shows them this math operation on a number line. 4 negative 3's equaling negative 12, starting at 0, starting at nothing. Here we are at number 9. Use the charged field model, another model, to show negative 3 times negative 2 is positive 6. Again, I know you know the rule, 2 negatives make a positive, and you'll teach kids that rule, but how do kids feel it? Like, why? Why is that true? What's the real reason? Let's see it. Basically, it's saying the first number, the negative 3, means remove 3 groups. That's what the negative is, right? Take out 3 groups of what? 3 groups of what? Negative 2's. So remove 3 groups of negative 2. So which one of these models shows us removing 3 groups of negative 2? C. See how there's 3 groups? 1, 2, 3 groups, each of them being negative 2, negative 2, negative 2. Removing 3 groups of negative 2, and it's going out. So we're removing 3 groups, negative 3, remove 3 groups of negative 2. And what's left? First off, what did we start with? What was in here to begin with? See how it's 0? Because the positives and negatives all are the same, so they just cancel each other out, and there's 0 in there to begin with. There's nothing. But so it's a fancy way to say 0 to begin with, right? All the positives and negatives are matched up, so there's nothing left. It's 0. But then when we remove 3 groups of negative 2, then this group is out, this group is out, and this group is out. What's left? Positive 6 is left in there, which is the answer to the problem. When you remove 3 groups of negative 2, you're left with positive 6. That model shows the truth of that math statement. That's important for kids to develop those deep feelings of the truthfulness of math operations. Okay, so on this one, in each of the charge field models to the right, the encircled charges are removed. So we're removing those circled charges. So what does that show? That shows that removing 3 groups, right? Negative 3. If it was positive 3, we'd be putting in 3 groups. But the negative says take out, remove, take away 3 groups of negative 2, right? See, negative 2, negative 2, negative 2. So that shows negative 3 times negative 2, negative 3 times negative 2 is positive 6, which is right there. And then what about the second one? The second one, we're removing what? Removing 2 groups of negative 3, and that's positive 6. There it is right there. Makes sense? Okay, number 11 here. Number of students in this cafeteria has been decreasing 25 per year. So every year, 25 less students are eating in the cafeteria. Assuming this trend continues, write a multiplication problem that shows it. Okay, so in the next 6 years, what's going to happen? For the next 6 years, there's going to be 25 students leaving every year. You know, 25 students less eat in the cafeteria. So that's minus 150. That's right here. Okay, 6 years ago. Now that's back 6, right? Now this was forward 6, next 6. This is 6 years ago, which means back 6 times negative 25. There was 150 more students, right? That's down here, meaning 6 years ago, there was 150 more students eating in the cafeteria, but they've been dropping out for the last 6 years. In years, the next in years, so that's like next 6, that's positive in times minus 25. That must be off my screen there. Option D. Yes, there it is. So next in years on number C here. Whoops, I'm writing it in the wrong spot. So in the next in years, That's positive n times negative 25. That's d. And finally, in years ago, that's minus n. That's back in time. Minus n times 1 is 25 is plus 25n. Right there, option A. All right, 35, we're going to do simple here. Two negatives divide to be positive 5. Negative and positive is negative 10. Now, what does it mean to have minus 3 over 0? 0 in the denominator means undefined, or you can't do it. There it is, answer B. Divided by 0 is not defined. There we go. Okay, here we are, number 13. We're supposed to work this one out. So that's negative 18 divided by negative 3. That's positive 6 times negative 6. It's negative 36. I think these will be easy for you. This next one, negative 10 times 3. That's negative 30 divided by 5 is what? Negative 6. Next one is negative 7 divided by negative 7. Is that plus or divide? I'm having trouble seeing that. That is plus. So negative 7 plus 7. That's 0. So negative 7 divided by 0? Not defined. You can't divide by 0. There's no such thing. Dividing by 0, there's no number that it equals. You can't do that. 0 goes into 7 infinite times. So it's not defined, meaning there's no number we can give it. Okay, over here now, we have negative 7 plus 7 again, which is 0, divided by negative 2 plus 2, which is 0. So 0 divided by 0 is also not defined. Again, we can't have 0 in the denominator. All right, last one here. Absolute value, remember that makes it positive 25, and then the absolute value signs vanish. Divided by, and this 5, well, it's going to be, 5 times, what's the parentheses? 11 minus 16 is negative 5. So this becomes positive 25 divided by, and these guys are timesing here, right? They're not adding, they're timesing. Negative 25. So 25 divided by 25 is 1. It's negative 1, though, isn't it? Positive divided by negative, negative 1. Okay, so this is kind of an interesting question. If x is an integer, which of the following are always positive and which are always negative? So they start us, let me bring this over here, negative x squared. Now, is that always positive or always negative or kind of neither? Well, you have to realize what it means. If there's no parentheses, see down here in a minute we're going to get parentheses. If there's no parentheses, then it means negative x times x. See, the negative is not repeated. There's only two x's, not two negative signs. On this one down here, we have negative x squared. So that one's going to be two negatives and two x's. See the difference between A and C? And then B in the middle, here, B in the middle, that's just two x's. There's no negatives at all. So everybody see the difference there. So here we only have one. The negative is not being squared, whereas here the negative is in the parentheses, so it is squared. There are two of them. So, and you know two negatives down here. You know two negatives. Make that positive x squared, right? Whereas this one negative makes that negative x squared, and this one is just regular x squared. Okay, so what does that mean then about positive and negative? Well, x squared itself is always positive, isn't it? Because any number you put in there, even if you put in like a negative 3 squared, it'll be positive 9, won't it? Any number squared, negative or positive, will be positive. So the x squared itself, just the x squared, is always positive. So what we really have here then is negative a positive thing, which is always negative. Did you track with that? This negative on something that's always positive makes it always negative. How about this next one? The second one is just x squared, which is always positive because it's just x squared. How about the third one? It's just x squared. So that's always positive in the end. It's just x squared, always positive. Okay, let's keep going with D and E. So here's D, negative x to the ninth. So what does that mean? That's negative. And then there's like 9x's, 3, 4, 5, 6, 7, 8, 9. So you know that. It's just one negative, though. Just one negative, 9x's. So what is that? Well, it cannot be determined. Why not? Well, because it depends. Let me put it back this way. It depends. If you put in a negative number like negative 2 or whatever, then this will be negative. Remember, you put parentheses around anything you plug into a formula. Negative, negative, and negative 2 to the ninth. How many negatives will that be altogether? 9 negatives and one more, 10 negatives. It's actually going to be positive. Whereas if you plug in something like x is positive 2, then this expression, negative x to the ninth, will be negative 2 to the ninth. That'll be negative. So it cannot be determined. It depends on what x is. See how that's different? Back over here when you have x squared, that's just always positive. X squared, that's always positive. It doesn't matter what x is. It doesn't depend on x. Any number you put in square, it's going to be positive. Even if you put in a negative, like a negative 3, squared will be positive 9, right? And this x squared right here is always positive, but then there's an extra minus on it, so that turns it to always be negative, you see. Whereas this one, if you have an odd power, basically, if you have an odd power, it's always going to be cannot be determined. Because that could be positive or negative. An odd power on x is always going to be cannot be determined, because an odd power could be positive or negative. You put in a negative number to an odd power, it comes out negative. You put in a positive number, it's positive. All right, so let's see it down here. How about minus x to the ninth? Same deal. Odd power cannot be determined. So odd power, it could be negative or positive depending on what you plug in. Okay, so a little bit of algebra here. Distribute. In fact, let me just do them down here. Distribute, distribute, distribute. That'd be negative f squared, positive fg, because negative times negative. And then negative times negative 5 is positive 5f. All right, let's do the next one. This is a FOIL. Yeah, let me bring it down here. Do you remember how this works from your algebra days? Foiling out, this first one goes to both. That'd be negative 36 minus 6f. He's done. And now he goes to both. Minus 6f minus f squared. That's negative 36 minus 12f. They're like terms. Minus f squared. So there's the answer here. Minus 36 minus 12f minus f squared. Now let's do the third one. Okay, so this is harder. We're going to have to take the f first to all three, and then we'll do the g to all three, and then the minus 3 to all three. It's going to be kind of tedious. 9 multiplications. Here we go. F squared plus fg plus 3f. He's done. Next comes the minus g. Remember, that minus is on the g wherever he may go. Minus gf, or fg, doesn't matter what order. Minus g squared minus 3g. And finally, the minus 3 is going to go to all three. Minus 3f, minus 3g, and minus 9. 3 times 3. 3 times 3, 9. So we got, what is that, 9 terms. Let's gather like terms. F squared, he's alone, nothing like him. F, G, and GF, they're the same thing. They cancel. Positive FG and negative GF, FG, same thing. They cancel. What else do we got? 3F. Is there another F? Oh, and minus 3F. They cancel. 3F and minus 3F, they cancel. Minus G squared. I'm underlining them or crossing them out or circling them or whatever. Minus 3g and minus 3g makes minus 6g, and then finally minus 9. There we go. There's the answer to that one.